Hey, welcome to this demo session. We are going to talk about big data and Hadoop in this demo. My name is Nagbhushan, and I'm going to be the instructor. And this demo is offered by IT Skills Training Services. What we're going to cover in this particular session would be an introduction to what big data is all about. It's been a buzzword in the IT, and we would like to really understand what big data is all about. And then I'll run you guys through some set of tools that are available on top of big data, the Hadoop ecosystem typically. So stay tuned for seeing some of those very interesting tools that we have that we would be doing after we understand what is big data and what is Hadoop. Now, if you look at, let's start with a simple data measurement scale. And let's start talking about how was data measured. Now, if you look at this particular scale here, we talk about bits and bytes of data, right? And we have, let's say, 1 kilobyte of data here. That is about 1024 bytes, which is kind of rounded off to 1000 bytes. Then we have a megabyte. Then we have a gigabyte. And if you see, it's for every record that we shift here, that it's getting multiplied by 1000. So terabytes have become common storage sizes today. When you buy a laptop or a desktop from the market, easily you get 1 or 2 terabytes of storage. Now, look at some of the records, some of the entries here. There's something called a petabyte, an exabyte, a zettabyte, and a yottabyte. The digital planet today has got 5 zettabytes of data, and that's so much, into 5. And that's a lot of data. When I say the digital planet, right, so it's the entire planet minus the data which is not digital. So it's coming in at a threatening speed, thanks to social media, thanks to IoT, and a lot of these smart devices that exist today. That's a kind of a threat that IT is facing in terms of how do I store this big data, and how do I process it. So Intel predicts that it's going to be touching around 44 zettabytes by 2020. Now that's getting multiplied, or getting doubled less than a year. So that's the amount of data that the digital universe will have in the next few years to come. Now there's a very interesting characteristic about this entire data that we've been generating. That is, once the data comes in, it never goes away. So the volume of the data keeps on adding. That's one of the attributes of big data called the volume. It's a human tendency not to let go data, and that applies even with each one of us. I click a photo on my smartphone and I let it be there. I don't delete it. So that's how I contribute to this volume, right? And over a period of time, the volume grows. The same thing applies to your enterprise as well. Once the data is generated, the data has, some business sense to it. So any enterprise wouldn't want to let go of this data. That's the volume part of, the big data problem. It's not there. Today we have data that's coming in different ways. One is, let's say Facebook, for example. You put, you update Facebook in terms of adding photos, videos, you like some photos, or you might comment something. All this is a kind of data that Facebook generates, right? And it has a lot of variety. The variety is the second V of big data. So we have the volume, which is growing, and we have variety. That's another attribute of big data. The variety aspect again has sub-classifications like, the structured data, semi-structured data, and unstructured data. And then the third V would be the velocity. There's a lot of speed at which the data is coming in. Twitter feed generates about 98,000 tweets every minute. Facebook generates about 600 terabytes of data every day. These numbers have a lot of speed in terms of the data that is getting generated. So essentially, these are the three V's that that are the attributes of big data. We categorize this big data as a problem to IT. Primarily two problems: how do I store this, and how do I process this? That's a real problem that we are facing today, and this is going to go worse because the predictions are 44 zettabytes of data. Yeah, and inevitably we are all generating data today. When you make a call, or when you send a WhatsApp, or like on Facebook, or you send out an email, all this is data. Or you make an ATM transaction, all this is data. That's gathered, that's generated for you and captured somewhere, right? So data has become an inevitable part of our life, and that's how it's kind of growing at a rapid pace. So having said that, these are the three V's that define big data. One is the volume, and the other one is the variety, and velocity. Now, Hadoop, what does it do, right? Hadoop brings in a fourth V. Hadoop brings in a fourth V here, and that is value. It gives you a distributed file system which you can use hardware. I mean, it saves a lot of money when we say commodity hardware. On the cheaper hardware, we can store all this data in a way that it's efficient, and the data, fault tolerant, automated failover mechanisms, and many features like this. So now I could distribute this big data into small chunks on a cluster that's made out of commodity hardware, hence saving a lot of money to my organization. All right, and commodity hardware in the sense that this hardware is prone to failures, and in spite of that, the framework offers fault tolerance. The data is always safe when it is on Hadoop. Now, these are some of the distinguishing factors, I would say, with respect to Hadoop in comparison with any other distributed file system, and that's where it brings in so much of value, and that's why it's kind of getting crazy now with implementations. Every project will have a Hadoop component in the next 1 or 2 years. It has become a part of every project today, right? That was on the storage front. And also on the processing, each of these local computes, let's say that I purchased 20 computers, and I connect them in a way that they can talk to each other, and I have a big file, 1 terabyte in size. I split that file into 20 small chunks and distribute them to be stored on each of these machines. Now, on each of these machines is a chunk of the file. It's not that 1 terabyte, it's 1/20th of that file. So it's a small file when it's residing there. That's how I distribute. That's what is HDFS all about. And it introduces a new paradigm of pushing the program to the data. Each of these 20 machines that I have, which I have as part of the cluster, I can use the local processor and the local compute, that's the RAM, to do a local computation on the chunk of the file that resides on that particular node, hence achieving parallelism, hence achieving faster processing. And those are again some of the features that Hadoop offers with respect to distributed processing. So not only that I have a distributed storage, I also have a parallel processing mechanism, and this cluster is built out of commodity hardware, and Hadoop is open source. So these are some of the distinguishing characteristics of Hadoop, where we say that it brings in immense value. It just doesn't stop there. There are many more things, but this is just an introduction. And how big can this cluster be? With today's Hadoop, that's Hadoop 2, the cluster size can go up to 25,000 nodes. That's a very huge cluster. It offers unlimited capabilities. That's what Hadoop is, right? And Hadoop has evolved in the last decade or so. It all started around 2006, and we are in 2016. Hadoop is 100% enterprise ready. There are many tools that have come up on top of Hadoop, and today one of those small tools that we will be looking at would be called Scoop. And probably Scoop would be that tool that you may want to use as the first tool on Hadoop the moment you think of doing a POC, a proof of concept, where you're trying to see if Hadoop fits into your ecosystem of your project. Scoop is spelled as S-Q-O-O-P. It means SQL to Hadoop. What it does, it can bring data from RDBMS, into Hadoop. Let's quickly take a look at, the Scoop website. It's managed by the Apache Software Foundation. Bear with me for a minute. Let me bring that Scoop website up for you. Now, this is what Scoop is. It's a tool designed for efficiently transferring data between structured databases, just like relational database management systems. And then yes, there are a lot of versions of Scoop that have come. This all started around 2012. However, we have Scoop, which is 1.4.6, which is production ready. Let's go ahead and use this Scoop to bring some data. Yep. I have this machine here which is running Hadoop. Now I run some commands here. These are some of the Hadoop related services which we are definitely going to discuss in detail as part of the Hadoop architecture, and that's where the entire course would focus on. Now, having said that all the services are running, right, let's quickly try and run a Scoop command. First, let's put this data into a relational database. First, I'll quickly connect to a MySQL database, and in here I'll just go ahead and create a new database called demo. And then I'll say use demo. If I say show tables, it wouldn't have any tables. That's why it's showing up an empty set. I'll go ahead and create a new table called EMP. This is a simple DDL. EMP is employee table. It has 3 columns: ID, name, and a department ID. I'll just use this command as query to create a table. Now, when I say show tables, I have employee. I'll quickly insert some records, just 3 of them here quickly, and paste it here. And now when I do a select star from EMP, it should show me all these 3 records. As I said, Scoop is there to bring this data into HDFS. So what we would do now is we will use some Scoop commands to bring the data. Okay, let me show you how your HDFS file system would look like. Give me a minute. I'm just trying to bring up a web UI for the Hadoop's name node, which is one of the master service. And you see here is the file system. Well, I've been using this VM for a while now, and there are some directories already created. What we will do is we'll go ahead and we don't have a directory by name Scoop demo, So I will create a directory by name scoop demo, and in that directory I would like to bring the data which is sitting in my RDBMS, that is MySQL. We are done with the MySQL thing. We have inserted the records. So I'll say exit. Okay. Now I'll quickly run a scoop command. Now I'm going to connect to scoop and connect to the demo database that we created. And we are going to bring all the records from the employee table to the directory scoop demo. Now this would trigger a MapReduce job. It's asking me for a password. I type the password and I hit enter, and it should now spawn a MapReduce job or a map job to bring the data into Hadoop. Now it's importing. It should take about a minute to complete this process. Now that's how simple it is to work with Hadoop. As I said, once you have this data into HDFS, then you can still continue doing your regular workloads, but the underlying file system can now be Hadoop instead of your traditional system. There are many tools like this which are available on the ecosystem, and what we would be learning as part of the course would be how do we configure and use them from scratch. We would give you an instance which has no packages installed. We would go ahead and download each of those packages from their respective websites, understand which versions are trending, which versions are stable, download the appropriate versions, install them, and run such hands-on. And that's what we specialize in. We give you immense hands-on, and that's when it brings in a lot of confidence. Now the Hadoop that's running here is called a pseudo-distributed mode. We saw those Hadoop services that were running when we started off with this machine, which means that all the Hadoop-related services have been installed in one machine. After this demo, I would also show you how do we set up a full-fledged multi-node cluster. Well, that's completed the job. It's brought in the records. When I refresh now, a scoop demo directory was created. This was the new directory which came up. In here, there's a file called part-m-00000. I can either read it from here, or I can come to the command prompt and say use a cat command to specify the path. These are some of the errors pertaining to Java and the VM. You can ignore them. You can ignore these warnings, but this is the file. These were the same records that we had in our RDBMS. Now they are available on HDFS. Okay. Well, that's how Scoop works. Now we quickly move on, and I'll show something a little more interesting: how to set up a multi-node cluster. Okay, bear with me for a minute. Well, I am using AWS. That's the Amazon Web Services. This is where I have subscribed for some nodes. AWS offers infrastructure as a service, where we can rent out machines, and I have kind of taken up 3 machines here, each of them with their own public IP and the public DNS, private IP and the private DNS, which we would be using to set up our multi-node setup. So I have 3 machines on which I would like to now install Hadoop services. Okay, and I'm using a SSH client called Putty. This is where I would like to install a multi-node setup on these machines. Yep. Now, I'll quickly run a setup file. Just bear with me for a minute. Okay, so I have it. All right, I'm going to run that command. It's going to take me to the Cloudera installer. I'm going to do a Cloudera deployment. Cloudera is one of the commercial distribution of Hadoop. So I'll just quickly accept the licenses. It is installing JDK, so it's an automated install. All the prerequisites will be automatically installed. So let's wait until this completes to 100%. It might take a minute. Right, so it's almost done. Now, all these details about how do we run with this installation and how do we monitor and manage the cluster will also be discussed. Now it's installed. We'll have to log into the browser and with this port number and with this username and the password. So we will, because it's not running on localhost, we'll have to give the IP address. This would be the IP address. So I'll pick this up. I shall open a browser and I'll say seven one eight zero. That's a little interesting. Yep, I'm on. I log in as admin and admin. So this is going to be my Cloudera installer. I accept the terms and conditions. Click continue. So these are the different additions that I may want to install. I'll select the Cloudera Express, which is free. I click continue. So the Cloudera Manager is like a centralized control system which will help me install and monitor the cluster. These are the packages that would be installed, and you see that these are some of the Hadoop specific packages. Apache Hadoop, which has HDFS, MapReduce, Yarn. Yarn is the new resource management engine on Hadoop. Then we have HBase, that's one of the NoSQL. We have Zookeeper for managing Hadoop and masters, and we have Woozy for scheduler. We have Hive, which is one of the data warehouse on top of Hadoop. Hue is the web UI for Hadoop. Flume is to bring in data, unstructured data. We've used Scoop previously. Flume will help us bring data, let's say, from Twitter into Hadoop and all that. Impala is one of a SQL that runs on top of Hadoop. Then we have Scoop and stuff and Spark, many of them. Yeah? So all these tools will be installed. I click continue. And this is where I'll have to specify the fully qualified domain names of each of those instances where I would like to install the services. So I'll come here and I would pick up, the IP addresses of each of those machines. or rather the fully qualified domain names. That's the first one. Select the second one, get from there. Sorry about that. And I picked the third one. Okay, so it's trying to connect. Let's continue. At this time, we'll just use the default settings. So let's not go with any extra configuration. Just click continue. So it's going to install JDK on all the machines. I click continue on this. Just give me a minute. I'll just quickly authenticate. Right, so we were able to authenticate there. Now it's going to install. See, on each of those nodes, it started the installation. And that's how simple it is to install a multi-node setup of Hadoop. You just need to, it's completed on one. And a lot about, how all this works and how to authenticate, what to do, the prerequisites, everything would be covered in detail as part of the course. Almost done it. The heartbeats tell that, each of those nodes respond to the masters. And that's how we were able to do the multi-node setup. That's a quick background on how to do a multi-node setup. All right, so I think that's pretty much I had. Thanks for watching.